Cool. All right. Good morning, everybody. This is the Kappa office hours, and for December 7th, we have a very light agenda. We're going to have Wei talking about VXLAN and potential ways that we could leverage that from like a CNI standpoint within KCS. Wei, I'm going to hand it off to you. Do you have a presentation, and do you need
Yeah.
privileges to share? Okay, cool.
Yeah.
Let me give you access. You are all good if you want to share.
Okay. Okay. So can you see my screen?
Yep.
Yes.
Thank you.
Yes. So I just have a very tentative presentation about how we think. I think the VXLAN can be useful for the for the multi-tenant virtual cluster. And basically, the VXLAN is kind of an IP over IP that we have two headers in front of a payload. The interesting part, I think everyone know a little bit about VXLAN, which is this kind of format here. But the interesting things I'm more focused on is this VXLAN kind of ID called the VNI, which is that can be used to make our virtual cluster as a single broadcasting domain, layer 2 domain, which is that give a kind of scope for all the pods, no matter where deployed. They still in the same network, kind of virtual networking environment, and this give a much easier protection or the security or the policy we can put to this this scope, so that we have an idea in a network space that this is a virtual cluster scope, and don't want to mix with other virtual clusters or virtual tenant. So this is the things we are more talk about. So given the virtual cluster pod IP, so in pod IP space, that normally pod IP is not doing this. Let me delete this. Yeah. So in the IP domain, that pod IP will not use NAT normally per Kubernetes requirement. So the idea is that we try to put all the so let's talk about this VTP. So which is an important component some guy use as an agent deploy on each host. So what the VTP doing is that it behave like a routing table, that it was not obtained by the monitoring of all the available zones, but it's really configured either by the central controller or based on the policies we are going to attach. So this is a VTP is a where we going to sync with the central database to make sure that all the mapping and the VNI will be configured locally, so that they can recognize which IP address belong to which virtual network interface, which is a VLAN, and how to encapsulate the outer IP headers into this virtual cluster based IP address. So now we still have creating multiple pods in a node in this scenario, that some of the pods belong to one virtual cluster with different namespace, and another two pod was belong to second virtual clusters. So in this case, we should have able to eventually tell the VTAP which namespace, which using which VNI IDs, and this can be done in a different way, but eventually can be synced to this VTAP. So when this pod going to get out and going to talk to any future far away other service or pod, this pod IP address will be attached with outer IP with the proper VNI, and this will be make this communication much isolated with this outer IP than with the VNI. So this is the basic ideas. So use VNI to isolate different virtual clusters. So in this case, and so with the advantage of a layer 2 broadcasting domain for the all the pod within the virtual clusters, the communication between the pods within the virtual cluster is much easier, because it's belong to one single layer 2 domain, and they can ping each other and can have much easier, simple policies to deal with their communication. But across this VNI zones need to go through the pipe, which is a tunnel with outer space and outer header attached and detached through the VTP. So this will be another layer of security that we can communicate with each other. So this is basically the things about the IP communication. And for the service cluster IP, so service cluster IP, unfortunately, I think most people still using IP table by using the kube proxy to configure the IP table so that the service is exposed to different order nodes. So the VTech actually have two flavors. If we use the IP table, VTech still able to VTAP is still able to deal with all the translated service IP with DNet. So this still works. So eventually all this VC service is able to go through the IP table and got DNet address or coming DNet address and translate back to the proper endpoint. After the IP table translation gets done, it goes through the VTP engine that can be based on the VNI name, and we can do the VNI number based on the DNet IP address, DNetted IP address, so that we can send to the tunnel to a different node or outside. So basically, this works. But for our virtual cluster, since we have two cluster IPs, one is virtual cluster IP, and one is supercluster IP. So we can actually put these two virtual two IPs all in the IP table to do the DNet in the same way, so that user can either use a virtual cluster IP for the service and still routable. We tried that; it just seems working. And also for the supercluster service IP, of course, it's worked by default with IP table, and it's been developed in the Kubernetes. There are no any trivial things there. So this is the way we can deal with still deal with IP table together with the VXLAN. So in this sense, that for the pod networking, so like a VMware or other folks, and we can use really a switch within this node to deal with all the mapping instead of using the IP table. So this is using a switch. We can still do this tunnel. It's one of the gateway or one of the exit point. Otherwise, without using this big open virtual switch, we can rely on the in-host routing table to deal with this connection between containers to the external VTAP and exit to the or egress to the physical Ethernet port on the node. So this is the basically what we I think of the things. I think yeah. So basically, this is how we deal with service and IP, and also deal with the pod IP using VXLAN.
Yeah, but I think the question is, if we use virtual cluster service IP, how do we resolve the conflict here? If VC1 and VC2 both have the same cluster IP.
VC1 and VC2 have same cluster IP. It's first of all, because this is always in the one VLAN zone, and it was not communicate using the actual cluster IP, but it's using actual outer IPs. So in this case, the VTP will put different outer IP address on top of this different VNI.
No, I mean, go to the IP table figure. I think there is a figure 5. sorry, slide 5.
Okay, yeah, this one.
Yeah, so if we still use quick proxy to change the IP table, I'm assuming this IP table is the host IP table, regardless
Yeah.
you use vtab or not. So all the paths in two tenants will go through that IP table anyway. So in this case, if VC1 with VC2 has a virtual service IP which has the same IP, I just don't know how do you resolve that conflict here.
This is a we can there are two possibilities. One is that we can put this here as well if we want put here before we do the VTP and do the IP table alter. It's a possibility. This is one possibility. Probably we can work around with this one because it's also an IP address, and we can deal with that after the VTP put into the pipe. Before exit, we can change this to this new no conflict IP address. But otherwise, you want to have in this case, the way it works actually is that we put a sidecar into it. So make sure this can be changed into the IP table. Normally we do this. So the sidecar can be configured to yeah. So conflict IP address is still an issue that we probably so this is your problem with the conflict IP address, correct?
Yeah, so that's the fundamental. So the way that we are talking about. So if you put a sidecar, so think about the analog part. It's like you have a kata VM. The sidecar is just a kata agent.
Yeah.
You did exactly what I was saying. The sidecar will change the guest network IP table to resolve the service. Because think about analog. So the network namespace support nested namespace, right? So you can still within each part you create a nested namespace and creating all the IP table rules for that nested namespace too, which is equal to for the kata writing the IP rules into the guest.
Yeah. So in this case, I think one of the options is that you can do this and put the IP table under the VTAP. This way, everything is clean and encapsulated with the VNI. So you don't need to worry about the conflict with the namespace, a conflict with IP address. So it's already be translated outer.
No, then in this case, VTAP has to act like Kubi proxy, right? The VTAP needs to read everything about tenants. And the VTAP needs to resolve the conflict of the virtual cluster service IP.
No, they don't need. Basically, VTAP need to be configured.
So how do you find the endpoint? I mean, if same class IP, how do you find two endpoints?
Yeah. So this, yeah, true.
So you bring so again, so it will like exactly what we did. I mean, not exactly. So you need to change the whatever binary that manipulated the IP table in the host, either VTAP, controller, or could be proxy.
Yes. Can you make sure this not using the same IP address, the virtual cluster? You can configure easily with your API server. You specify a CIDR in your controller.
The problem, the CIDR it's not full range. In Cloud Vendor, we only have three CIDRs to choose.
But you can use any, because the virtual IP address within the cluster is arbitrary. You can use any virtual IP address. So you don't need to worry about CIDR, but you put into 10 dot something for the VC1 and the 12 dot something for the VC2.
there's a high chance they got a conflict, right? I mean, there is a chance.
No. You just make sure this is in the 10 some domain and other virtual cluster in the 20 domain.
No, so
and there are
as I said, we in Cloud Wonder we only have 3 choices, either 10
Okay.
or 192 or whatever. And in most cases, you
Or
only
100
give,
net, I'm guessing.
yeah, I only give we only give 10 something to the user.
Is that specific to the Ollie Cloud like control plane creation aspects and where your API servers actually run?
Yeah,
Gotcha.
it's like
This is the difference between like using VC Manager and creating pods that run the control plane versus using Ollie Cloud, where you kind of have like a very specific service that you're integrating with to do your actual control plane creation.
Yeah,
So
I think Cloud Wonder cannot give you full range of the IP.
Yeah.
They have the limitation. I think AWS has the same thing.
So there is a weird kind of a doing 3-layer of the encapsulation. This is still a possibility, but it's very heavy. I think VMware is proposed a 3-layer of the encapsulation, which is 3 headers on top of the. We are talking about 2 now. So there another layer. So in this case, you have a VTAP just in the Docker, and you have a multiple aggregation layer underneath. So this is the how it can also work this way, that you encapsulate multiple layers and make sure your IP address was kind of neutralized with no conflict.
This is so the real IP. There is no conflict, no problem. That's okay.
Yeah.
The problem is the service virtual IP can be conflict. And
no. In this case, you translate to a real non-conflict with the VTAP before exit out.
Who does the translation?
The translation is configured. The VTAP is configured by the admin. That
no, I'm saying that okay,
table.
VC1 and VC2 have 2 services, and then they have the same service class IP in the VC.
Yes, in the VC. Yes.
And if you come to the 2 services into the host, so they are pointing to 2 different endpoints. How do you decide which endpoint the service should point to?
Yeah, so this is identify with different. So even though this is a namespace, so the VT1 is namespace 1, VT2 is namespace 2. So this VC1, whatever the IP address, will translate to a non-conflict outer IP address, and this outer IP address will be used for routing entirely to this. So
then VTAP 1 and VTAP 2 needs to know. I mean, check the API server to guard namespaces.
Yes, this is where heavy, because VTAP is not a routing table generated by itself. It's a routing table basically configured by the admin, and this way you can do whatever you want to make sure this works properly. So you have a table like that. You can configure the namespace to an alter IP and put the different VNI name into it.
No,
this way,
what I can see is that you just create a namespace. So the whatever VTAP need to watch the superclass API server, get that namespace. So first get that namespace, then
no, you're talking about the virtual cluster API. So this one only need to talk about your virtual API server.
Again,
API server, yeah.
So then think about this M2. You have VTAP 1 need to talk all VC.
Talk to one VC.
All VC, because I mean all VC can have a pod in the same node.
Yeah. So this is where we have a big database. So the VXLAN has a big database in somewhere, and you have to synchronize all the VTAP endpoint to a global kind of a domain. So this is a central database and know all the policies or the VC. So all the VTP to update their policies to talk to decentralize the server so that they can make all the proper
so you have a big synchronization points to for all the VC, for all the virtual cluster, you need to have a table for the service and endpoints and a name and a namespace. So basically,
in this sense, yeah. But this is only for the outer, but for the inner. So this is the implemented details that what they need to negotiate is their outer IP, make sure they're not conflict, so that when they get out, they can route properly. But internally, who they all belong to same outer IP with a different, So they are, they need a translation. They need a translation and sync all together. So the more we tap, you get more translation or synchronization work need to be done. It's have to have this synchronization work be done.
Yeah.
You have to negotiate a proper IP address for the conflict one, outer IP.
So yeah, that's the reason I said the way that we resolve this is pretty, have a scalability problem. The way that we resolve is we talk to Kata agent, we change the guest IP table, and we do a filtering. So to make sure you just inject the proper service for that namespace for that pass namespace in that pass guest IP table to reduce the duplicate that at a non-used service IP IP translation rules into the IP table. So that's what I was talking about.
Okay, so but you still need to finding a proper destination net for the IP table to make sure they're not conflict, correct?
Yeah. But that's the reason we changed the Kubi proxy, because Kubi proxy knows everything. The Kubi proxy talk to superclass, the superclass, and we put the guest virtual guest service class IP into the superclass service annotation. So I mean, Sync does that. So then in the Kubi proxy, they knows everything for this service. What is the class IP in the supercluster? What is the class IP in the virtual cluster? Then
this. Oh yeah, okay. Yeah, this is of course we did also. I did also a prototype for that. I know. Yeah, this is for sure we can do that. No problem. It's kind of local translation.
Exactly. This is that sidecar that you did, but they're doing it at the actual physical host level to push to every workload that's running on the node, which I think makes it even more scalable because you don't have to have the connection back from every single pod, kind of like what we were talking about last week, which I think makes perfect sense. And like,
no problem. Yeah, I totally agree. You can do that. No problem. Even here, you can do that. The beauty of the VXLAN here is of course can solve, may not solve your situation perfectly, but it does give a virtual cluster a domain, which is a layer 2 broadcast domain, which is
This is the overlay network. So in the cloud, the analog is VPC. So VPC will achieve almost the same thing as your VXLAN.
Yeah.
So because you talk to the separate switch, it's a software switch. So then there's a nature-bound isolation between two tenants. That's exactly what we did in the cloud base, right? Everybody has a VPC. Analogically, you hear is every tenant has a VXLAN, which is perfectly fine.
Yeah,
but again, as I said, so the top part for service is the translation. And if we see class IP has the same class IP, you need to resolve that conflict. That's a bigger thing, which I don't think VXLAN can be done easily. So if you say, okay, every tenant needs to talk back, I mean, then it's okay. I mean, but it's just architecture choice.
Yeah, I think for the translation, using this things is a little bit too heavy. I totally agree. Just for the translation, so you can do this translation here and make the conflict solved. Then we still we put the one V tab each host is a kind of a reasonable, but not too much.
I mean, so since again, so it's like either change. Just forget about the kata. So you can do even more tricky, but you need to have a significant way to change the network CNI plugin to support a nesting namespace. You can do almost the same thing.
Yeah,
you could just create a V tab. I mean, in each part network namespace, create another layer.
Yeah,
and push the IP table rules in that inner network namespace, and that's exactly what our kata does. You can do that using the upstream, but use upstream, non-sandbox container CNI plugin. But that's a big change, and you need to change the Kubi proxy anyway, because Kubi proxy has to be aware of the tenant.
Kubi proxy just a configuration module. That's the work. The data
but you need to change. But you need to change. You need to change Kubi proxy to enter the right namespace.
Yeah.
And which is has to know the tenant. They need to know which tenant it belongs to. That's what I was probably.
Yeah. That was what you were talking about last week as well. So on that note, on the changes that you had to do, did you happen to have a chance to talk with anybody from your group about trying to figure out if that's something that could be upstreamed, like what we did with the CorDNS instance, where we kind of have at least a diff for what would need to be changed?
I asked internally, so I mean I don't know, because I think the plan is they're trying to push to Kata 3.0.
Okay.
Yeah.
Now, does Kata 3.0 add some new functions that make all of this even easier? And I'm not too involved in the runtime side of things.
So my theory is the Kata group will leave it open. So I mean, so if somebody want to integrate, we have to do the integration. I mean, then most likely we just give you an interface. Most likely.
Sure. Yeah, that was kind of what I was hearing from our side of things as well. Talking with our internal people that work on Kata, is it's like, yeah, we want to make it a common interface that all of these things that could be piped through. And so as long as that is something that's in place, then anybody could do this.
So do you guys plan just, is the micro VM Kata is the right way to do, or you still want to run C in the beginning?
That is our plan. Kata,
okay.
Yeah. So we'll be paralleling very similar paths to what you're trying to do there, or what you are doing there, and trying to figure out how to basically, in essence, implement the same things that you've already done.
I'm guessing. So what is the networking plan for Kata? Use VXLAN for isolation, like exactly the way it does, or?
We have a pretty custom network stack that we have to integrate with. So it'll be integrated into that. Does that use VXLAN today? No. Yeah,
we're trying to push it.
Yeah,
we'll try to push it, but our network stack is hard.
I mean, people will argue the latency. I mean, throughput. You have to do the experiment.
Is that what you experienced as well? Wait, the latency of what? From
package?
Which part? Yeah, from VXLAN.
Yeah, but it should be. I mean, in general, it should be okay because it has hardware support. In general, the switch needs to support it, right? So, but
translation is not a big deal, because it's really after the table was downloaded to local VTAP. It's just a software switch, like a routing table. There's no any extra header, extra stuff too much to worry about. But the synchronization does take time.
Again, it depends on application, right? So normal application should be fine, but it depends. I don't know what kind of application. Some people is very paranoid about any latency. So you add one, you need to add that. You need to change that header, right? by software.
Yeah, I think we're looking at the VXLAN a little bit from where we want to go with like the multi-cluster aspects, I think more so than the single, more than the
the thing is about the scaling, right? Think about it. So Flannel use VXLAN also, but it's a very simple VXLAN. There's everybody,
single one for everybody.
Single one for everybody, right? There's no scalability problem. Now think about it. You have a node once 100 node, 100 pods belongs to 100 tenants. Then you have a 100, VXLAN. For other VTAP devices, you need to prove there is no problem for that.
Our plan there,
we have a lot of workaround for that, right? So, for example, we using the hardware in FPGA assist networking. So we put Intel vSwitch into FPGA. So it's the hardware assist networking. So make sure the performance. I mean, it brings other problem, but normally okay, because when they come with that hardware plan, they need to do the evaluation. So then for the cloud is very, 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 very standard, like AWS does, right? VPC does. They point to the virtual software which running somewhere.
The big advantage of the VXLAN is that when do the hot migration, that you have one pod need to be hot migrate to another node. In this case, no IP address change, and only VTAP was configured on other node, and everything keep the same. So this way you can enable the hot migration. If you don't want this feature, of course, it's questionable if you need to this overhead. But the hot migration, I don't see any networking can do that without big IP table change, routing table change. So
Yeah,
hot or cold migration is the most important feature. If you you have to have the VXLAN.
Yeah, that's also the longest debate I have ever seen. I mean, for not longest, but so people will argue that, I mean, from technical perspective, we want that hot migration. But in reality, there's no single team can do that. There's no single team can do that. It has to be a collaboration. Unfortunately, it'd be always the lowest priority in the OS team for that. It depends whether your workload really need that. I mean, for the Kubernetes, compared with VMware, so VMware, the hot migration is the key. I mean, the key. I would say the most, fascinated or valuable, value for that VM management is the hot migration. And I used to that, so I'm surprised when I moved to Kubernetes, it doesn't support it. But
but with VXLAN, you can just frozen the image on the node and put this image to the another node and start up, and everything should be keep same. This can be done easily.
There's a lot of subtle things. So, but it depends which technology you want to use, right? So, I mean, even for just the state, for memory states, you have CRIO, which is very classic container migration technology, just dump, snapshot. And,
yeah.
So, but for micro VM, you need to have new implementation. You don't have, you don't want to run CIO inside the guest, which is possible, but there is a problem. You need to select a new guest in the end. So you'd better snapshot the VM, not snapshot the guest. A lot of other things. I mean, networking IO is just one part of it. How about storage IO? So I don't know which driver you guys use. You have to enforce the shared storage, right? Normally, you have to enforce shared storage. Normally, again, I don't know. So do you guys have a plan for that? That would be very
for shared storage?
For hot migration container, container hot migration.
I can't say that we do.
Yeah.
So I mean, it's something that's like anybody that gets into the container world, that's a caveat that everybody has to deal with today. So yeah, we're kind of resting on the community provides what the community provides and what we have controls around.
As far as I can see, the only one that I would say production ready kind of thing is not hot migration. It's just like snapshot.
Yep.
Snapshot and freeze the space, freeze the resource. Save the snapshot in the disk and free CPU and memory run.
Yeah, there's some new startup as well that was doing something in this space. I forgot, somebody pointed me to it a while back. When I was trying to figure out why people would go VM substrates first these days, like if someone were to be interested in that kind of thing.
That's for utilization, right? You just snapshot the entire your online job at night and run offline training job during night and resume the online stuff in the morning. So just take the time multi-proxy.
Perfect example.
Yeah, to save to improve all of that. That's exactly what we did. I mean, for Alibaba, like e-commerce company, they definitely use this kind of trick to do improve the utilization.
Interesting. That's fascinating to hear. Huh. Okay.
And I tell you, that's in production, so that's actually doable. I mean, with the CRIU to do the snapshot and snapshot and resume.
Interesting.
But again, it's not a very genetic solution. You need to build an Intel solution for that, Intel technology or Intel software for that. I mean, only for that scenario. I mean, I don't see other scenarios because it's not automation. It's not a scheduling, intelligent scheduling decision. It's no. It's
right. So this is for your very rare kind of a application that need to be up and running for several seconds. So in every day. So this way you froze it.
I think Apple probably the same thing. If you watch all your application patterns, definitely you will see patterns. Applications are busy in the daytime, but very idle in the nighttime, right?
Yep.
And on the same time, you will always have training jobs. I mean, 24 hours.
Yep.
So then you can squeeze some resource at night and let it run in training. There's no, I mean, overall cost utilization can be improved.
Yeah, scheduling workloads that specifically need the resources at specific times, and trying to filter, or trying to like almost scale to zero in essence, for all these things, for things that don't need to be run 24 hours a day or regionally or what have you, for sure.
Yeah, it's a really complicated implementation. I saw that Uber did that, Microsoft also something like that. But
I mean, if you have a dedicated infra team, so most likely you will do that.
yeah, it's a lot of work. I was kind of investigate a little bit on that. It's a lot of work to deal with, especially get back
So in
to the
VMware, we were trying to do this in the just purely stick scheduler thing, just because if you have vMotion, I mean, you can do the trick. You just migrate all the idle VM in this overcommitting in a host, and that's it. then that's we did in the past, because I was writing the scheduler in the VMware, so to kind of resolve this kind of problem. But unfortunately, I mean, I would say that's much cleaner solution. Scheduler,
Sure.
plus motion, everything's automated. But now you have to put human resource to do it manually.
Sure. Interesting. Very cool.
Okay.
Sweet. All right. Do we have anything else we want to talk about?
Not in my side.
Cool. I think I'm good from my side.
Okay.
Thanks, Wei, for putting that together. It was good to have that conversation and talk through all
yeah,
this.
it's interesting to know a lot of use cases.
Yeah, I am curious. I'm curious to hear if you get any more feedback, Faye, from your group. I would definitely be curious to understand more, since we'll be looking into it from like whether we want to run kube proxy is I think the biggest question for us, since we've tried to avoid that as just a known common failure within Kubernetes. Yeah.
So say it again. You are thinking not running kube proxy?
Well, I mean, in general, so we don't today. Just from a scaling standpoint, we did not want to deal with the scaling targets around kube proxy, and so we've avoided that specific component within our architecture. Now, if we go the path of what we've been talking about, and we try to use Kata and all of those things, we'll be bringing that back into our environments, which is something that we're not exactly stoked about doing. Just because, like, I mean, this is one of the biggest components that falls over, that we've experienced, that falls over. So you're obviously already hitting larger scale targets than what we have. So understanding like what it is that's making it different.
About the problem. So another track, I'm not sure if you guys handle that, is do you guys plan to go to IPv6?
Yes, we're heavily invested in IPv6.
So if you go to IPv6, the class IP, I mean, conflict can be easily resolved, because
everything routed over v6.
Everything
for everything.
You can give a segment for every tenant. There is no conflict. So it's much simpler. There's no this kind of IP table thing.
We can't make a claim that we won't have v4s though. That's the big problem. We're going to have some things that don't support.
You can still have a v4 as long as your infra support v6. You can do the translating between the v4 to v6 in the infra. If your infra cannot support v6, then you have a big problem.
I see. Interesting.
Think about it, right? It's all about host IP table.
Right.
So another question, Faye, if you change the IP table this way, are you going to also change the firewall policies and the ACL, AL?
But this control? Is kind of, because all these kind of things are attached to VPC, it's part of VPC. In our cloud, there's no problem because we use the entire VPC management tool chain. So no change.
Okay.
So because each tenant has a VPC. I mean, all the firewall, all the security group is attached to that VPC.
Okay.
Oh, so you're actually translating VPC endpoints into the Kata containers. So the security policies live in the VPC. They don't have to live. I see.
No problem. There's no problem.
Fantastic. That's very cool.
Yeah. If we deal with the IP firewall, then also ACL, then we're not just changing the DNAT, then we have to also adapt to the policy, which is a little bit complicated.
So, Faye, if we can talk through that real quick. So when your clusters come up, say for instance, you go provision a control plane with Ollie Cloud that then gets hooked up into VC Syncer. you have additional components in there that then configure. So no, your kube proxy then goes and configures. How does it know about the VPC endpoints in there? Or no, it's only service IP, so it doesn't matter. Yeah. Okay. Got it. Okay. So it's just the nodes have to know. How does that work though? Because that means that every single node that has workloads has to be attached to multiple VPCs. Physical node.
The physical node need to attach to multiple VPC. Yes.
I see. Do you hot swap that like as workloads get scheduled onto those? So like this node has
I
five
don't know that.
workloads. All of
I don't know that details, but
okay.
This is not a common situation for the cloud.
Yeah, that's a very interesting way of structuring it. Yeah, wait, like that's way outside of our scope these days. Interesting.
I mean, in the end, the cloud vendor. I mean, technology no problem at all because think about VMware.
It's all APIs. Yeah.
Right. Technology VMware is just each VM can have virtual network, and you can support 1,000 virtual network with no problem in one node. In one host. No problem. Technology, no problem. It's only for security perspective. How do you want to make sure? It's not a common. I totally agree. It's not a common. So in general, usually in the cloud vendor, each host can only attach to one VPC.
Yeah. That's I think where I was trying to get at. I was like, that's very confusing because like, I mean, I couldn't go to AWS and basically attach an EC2 instance to 10 VPCs and have 10 different workloads running on there, all talking back through a single VPC, unless we had VPC endpoints that were then connecting those pieces.
VPCs can allow the multiple VPC, right? Can it? But yeah,
per EC2 instance?
Yeah. Can you? No.
I'm pretty sure. No, I'm pretty sure VPC. A node lives in a specific VPC. A host lives in a specific VPC.
I don't know, but it depends. I mean, I'm pretty sure there are customers they will request this. Maybe it's just case by case.
Sure.
I just read yesterday the AWS CNI is allowed to create as much kind of a virtual Ethernet port as you want. So this can be managed for each VPC.
Yeah, the hard thing is if you attach two VPC in one VM, you need to write that. I mean, the routing table inside the guest very carefully.
Yeah, absolutely. Interesting.
And we have tools to do that. I mean, for some customers, they ask that, we have tools to do. I mean, to make sure the routing is not conflicting. But I mean, this is outside. Normally, we don't do that.
Yeah. Interesting. Okay. Cool. That's good to know. Yeah, that sounds intense to deal with. And you're right. Wait, I mean, you can technically do like ENIs, multiple ENIs attached to them, but I don't think those can. I mean, maybe the ENIs can then peer to multiple VPCs, but I'm not positive on that. I don't believe they. I mean, I guess you could peer.
In CS case, right? That host must be attached to multiple ENI. No, otherwise, how can you support a VM, right? That physical node you need to attach to different VM.
What? You're talking about the physical host under the hood, not the VMs.
Yeah,
I see.
Not
the VMs. Yes, the physical host can.
Yeah.
Yes.
So in our case, we are talking about the physical host. We are not talking about the VM.
Gotcha. Okay.
In our case, right? We are not talking about VM. So
right, you're talking about the bare metal. The
bare metal, right? It's a bare metal host.
Yeah.
Each part is a VM. That part only have one VPC. If you attach two VPC, you need to play with the guest routing table. It's not IP table.
Yeah.
Okay. Yeah, this makes sense. You have a VM, you don't need to worry about two VPC in the one VM, adding more complexity.
But in this world, your VM is caught at that point, and that's where you're attaching all of those things to. Gotcha. Very cool. Huh. Sweet. Thanks for giving us that information. That's very fantastic.
Yeah, in general, you don't have too much choice. This is probably the only way.
Yeah.
You want to support multi-tenancy. I mean, in the cloud is pretty normal.
Yeah. Cool. All right, folks. Anything else?
Okay, cool.
Awesome. Y'all have a wonderful day.
Okay.
Bye.
Yeah.